This is one of the most important question and it has lot of subtopics to cover. And the question is what patterns you have used in your project for microservices. So usually in microservices we will use various design patterns, right? Such as communication patterns, data management patterns, fault tolerance and more. Here I am listing some of the key patterns that I or we use commonly in our projects, that is in microservices projects. In a microservices project, the most important one is the API gateway pattern, which acts as a single entry point for all client requests, routing them to the appropriate microservices. It also handles cross-cutting concerns like authentication, logging, rate limiting, and load balancing. Here you can see in the diagram we have 4 microservices and there is a gateway before them. Whenever the request comes from the client, whether it's a mobile or desktop client, request go through the API gateway, then it routes the request to the respective microservices. One of the main advantages of the API gateway is clients no need to know the multiple URLs of the different microservices, right? If they know the gateway URL, they can call the respective API seamlessly. And coming to the next design pattern we generally use for the fault tolerance is circuit breaker pattern. It prevents cascading failures by stopping the invocation of a service that is likely to fail. Okay, suppose on heavy traffic, if one service fail, that should not affect all other services, right? This is where circuit breaker pattern is handy. You can go through it. I'm not exploring them in details here. And one more important design pattern in microservices architecture is service discovery pattern. This pattern allows services to find and communicate with each other without hard coding the network locations. It also enhances the scalability and flexibility and supports dynamic service registration and discovery. So simply you can say it's a central service where all the microservices will register, and whenever they want to call each other, they will just look up in this registry to call the respective service. Likewise, in microservices, we have other important design patterns like database per service pattern, event sourcing, sagas, transitional patterns, bulkhead pattern, and centralized configuration patterns. Really, all these are very important for the microservices architecture. You can explore them individually. Anyhow, I will cover all these in our upcoming tutorials. We have 3 more questions left. Let's move to the next one. And the question is which gateway you are using in your project. So you can tell whichever the gateway you are using for your project. Usually we'll use the Spring Cloud gateway for the microservices using the Spring Boot. So I'm explaining here the key features of the gateway here. Okay. So usually Spring Cloud gateway, it provides webflogs to build reactive scalable API gateways. Okay. Spring Cloud gateway also supports common aspects or concerns like routing, filters, predicates, resiliency, security, and extensibility. Extensibility is nothing but adding more custom filters to secure the routes. You can see a sample of a configuration for a Spring Cloud gateway. This is how usually we will define the routes. Every route we will just define an ID, we will give the URL. Here the predicates are used for route matching and decision making based on request attributes, whereas filters are used for modifying requests or response or for additional processing after route has been matched by the predicate. To explore in depth on Spring Cloud Gateway, you can go through this official URL provided by Spring. Now let's move on to the next question. This question is about one more design pattern from the microservices, that is load balancer. So the question is which load balancer you are using in your project. So generally we'll use different type of load balancers depending upon the deployment environment and the requirement of the project. From the Spring perspective, Spring Cloud also provides a load balancer called Spring Cloud Load Balancer. It works seamlessly with the Spring Cloud Netflix, Eureka, or Ribbon and other Spring components. Here Eureka is a service discovery client which is provided by the Spring Cloud Netflix or OSS, and the Ribbon is client-side load balancer. Here is the sample configuration for the Spring Cloud Load Balancer. You can go through. If you are using Kubernetes, it is also providing a native load balancer called Ingress. You can explore about that also. Or else if you have AWS environment, it supports elastic load balancing, ELB. This ELB has multiple types like application load balancer and network load balancer, and one more called classic load balancers. Basically these LBs are two types. One is software load balancing or the hardware load balancing. Okay, it's also a huge topic and you can explore about that. Now let's move on to our final question, that is number 15. This question is again on the load balancers, and the question is how this cloud load balancer actually balances the load. So usually what these load balancers do is they distribute incoming application or network traffic across multiple targets. Those can be servers or application instances to ensure no single server become overwhelmed or overloaded. So let's explore the mechanism of this load balancing. Generally, there were two kind of load balancers, that is hardware and software load balancers, and these software load balancers follow different algorithms. I have named here some of them, you can go through. I have also designed quick visualizations for some of these main algorithms like round robin, list connection, and list response time LBs. If you have around 3 to 5 years of experience, I don't think you require in-depth knowledge of these load balancers, but I recommend you to go through at least clear the basics of these load balancers and different algorithms so you will be confident for this microservices pattern.